Video, we divided into two parts. The first part, we'll be showing you guys our failures. So there's been like 2 to 3 prototypes that didn't turn out as planned. So we'll be showing you how step by step we tried to correct our mistakes. And on the second part, we'll be showing how the pot boat actually turned out better than we planned when it actually moved. So in the first part, it would be boring because there's a lot of failure, but bear with us because in the second part it would be really exciting because you'd see the pot boat just made out of cartons, straws, and aluminum tin cans moving just like a steamboat would. So watch out for that. Thank you.
We're testing the pop-up boat for the second time. As you can see, nothing is happening yet. We are waiting for steam to do its thing. The pop-up boat is not moving. This is the third body of the boat, and this is also the third engine that we have tried. As far as you can see, it is still not operational, and we must have to try a different engine. But the boat, as you can see, floats, so that is progress.
So this is the pot boat. This would be a prototype number 1, the one with the root beer can, and prototype number 2 would be the one with the Sprite can. Right now I'm setting it up. I'll be priming it with some water. I'll put the water in the straw, and once it's ready, I'll be putting in the candle, lighting it up near the engine, and hopefully it would start putting. Thank you. Test the 2 prototypes. I'd just like to show these 2 originals. They were the first prototypes which we tested, and as you can clearly see, it didn't turn out the way we planned. There were holes in the hot body, and this is another engine that we tested, and as you can clearly see, something went wrong. The body was just able to contain the water, and because we didn't use epoxy, there's a chemical reaction that happened that set the aluminum can on fire. So as you can see, it's burned on top. Final note, we just like to also show you our hull. So this is for the design, and we just put it on top of one of our prototypes, and it gives it its boat design. To show you how we actually prime the boat. So what we do is we get a bucket of water, so we just fill it. Fill the straws up until water comes out of the other end, and then we just close the end, and we move the water around so that tiny water particles would come this point near the end of the aluminum can, and that's what we're going to steam with the candle. So the candle and we'll just place it below. There it is. Now the pop bubble moving. There it is. Now you can see it takes a long while before it starts, but when it starts, it moves. So yeah, it's continually moving. And don't worry, that pot sound that you're hearing, it's not coming from me. I'm not farting, but it's coming from the pot boat. That's why it's called the pot boat. It makes that sound. Prototype number 1 didn't work out as planned, but the prototype number 2 did work, and it did pot. But now, in our experiment, we checked that if you make the hole of the straw smaller, it would actually make the pot go faster. So while we're fixing prototype number 1, we'll jump and try to experiment with prototype number 2 by making the small holder smaller. So we do that by taking two bits of straws, and putting them inside one another. And here's one more. And then we'll just place these two inside the holes. We'll prime it again. We'll put the candle on, and we'll check if it actually goes faster. Okay. With a smaller straw end, let's see if it goes. Oh yes, it goes faster. Look at that. Wow. Okay. There it is. As you can see, it is definitely going faster than the first time. By definition, there is a law which works. It's called the law of diminishing returns. It says that doing one thing makes the benefit smaller. So that means that you can only make the straw end smaller to a point. So if it becomes too small, it wouldn't go as fast. The diameter of the straw right now, I think it's at its peak. That's why the boat is going as fast as it possibly can. There it is. So, even with a smaller candlelight, it's going faster than before. Yeah. So, based upon this evidence, we can say that our hypothesis is right on the money. prototype number 1. Oh wait, it's moving. There you go. Pot boat number 1. It is moving. As we can see, it is moving slower. The first one is right. Prototype number 2. But there it is. It's still moving. Listen to the pot sound. It's pretty strong. Maybe it's even stronger than the first one. Look at that. That's how a pot boat should move. And so we can see that the law of Newton's third law is being applied as well in this toy boat. The motion of the water as it is jetting out is actually causing the boat to move in the opposite direction. So there we go. I think the candle, it's reaching its end, but still the pot boat, it's still moving. So it has slowed down quite a bit. Oh, but there's still some pot left. There it is. Pot boat, prototype number 1. It is up and running. So now we'll just check if the hypothesis is also true for our prototype number 1. That if we make the diameter of the straw end smaller, will it actually cause this boat to go even faster? So let's check. There it is. There it is. It's the pop boat prototype number 1 with a smaller diameter. And as we listen to it, you can actually hear, it's moving pretty fast. I mean, we've put the tiny straws on the straw end to make the diameter smaller, and so in theory, it should definitely go faster. As we listen to it, the sound of the pot is definitely stronger right now compared to last time. So there it is. I mean, both prototypes work when we put there the smaller straws on the straw end, and the pot boats, they moved faster. So that could be evidence to prove that if you make the diameter of the pot smaller, it would go faster. So it's actually moving like the hose. Like when you put your thumb on the hose, water would jet out. And so it's the same thing with this. When you make the diameter smaller, the water rushing out of the straw, it's jetting out. And so that's what causes the pot boat to go faster. So I think this has proven our hypothesis. And so thank you for watching. Thank you.